Hi, welcome everybody. My name is Shawna. I'm a senior data scientist with CGI, and today I'll talk a little bit about how to avoid the oops using MLOps. So you may be familiar with MLOps, but I'm sure a lot of you are wondering, what's the oops? So within the GCP documentation, there's this statement, and it says, the real challenge isn't building a machine learning model. The challenge is building an integrated machine learning system and to continuously operate it in production. Even the brightest companies like Google have challenges around machine learning operationalization. So let's see how MLOps can help us prepare for this challenge. MLOps allows us to tailor tried and true traditional DevOps practices to machine learning technologies. The foundations of MLOps are strongly rooted in automation across the entire machine learning lifecycle to foster agile teams and reduce technical debt. Within MLOps, there are two main themes. First, development and deployment. So focusing on automation in development and training and in environment deployment. And longevity and maintenance. So here we have our model in our environment. Maybe we're making predictions in production with our model. But the machine learning lifecycle isn't over there. We're focusing on keeping model performing well and making accurate predictions in our environment, even well as the outside factors start to change. Within development and deployment, there are three accepted levels of maturity. So the youngest level of maturity is manual processes. This is a very hands-on and involved approach where developers and data scientists work together to manually train models and manually deliver the models to the environments. This level of human interaction is tedious, it's time-consuming, and it leaves a lot of room for human error. Manual processes work great for things like initial exploration and proof of concepts, but really they're risky and they tend not to scale too well. And as we walk our way up the levels of maturity, we strive to abstract our automation to a real deeper level. Continuous training works to modularize and begin automation in the model training process by incorporating machine learning model training pipelines as the deliverable. In this level, the model training pipeline is manually delivered to the environment, which in turn automatically trains the machine learning models. Taking maturity one step farther by automating the machine learning pipeline delivery. And this is done by incorporating principles of CI/CD, which I'll talk a little bit more in a minute. Commonly, we'll do this by integrating version control and build pipelines to trigger automated build and deployments. Here we have little to no manual processes aside from the true development efforts. This works to lower the barrier to entry for machine learning productionalization. Now, coming back to CI/CD being traditionally a DevOps principle, let's see how we can translate this a little bit more into the world of machine learning. At their core, the principles are still the same. In continuous integration, we plug into our version control and use things like pull requests to trigger automated testing. But in continuous delivery, rather than deploying artifacts and software, we train and deploy machine learning models to the desired environment. And by stacking these two together, we're able to bridge the gap between development and operation by relying heavily on automation. But again, this only takes us to getting our trained models into our production environments. And our machine learning lifecycle doesn't end there. What happens when our model is making predictions and the predictions inevitably begin to degrade over time? Supervised learning is, at its core, just function approximation. And the world is constantly changing. And this causes our machine learning models to lose predictive power over time. And this is what we call model drift. So model drift is comprised of two types: data drift and concept drift. Data drift happens when properties of the independent feature variables change over time. So these are the inputs to our machine learning models. Since our model did not have any of this drifted data in the training set, we're likely to see a decline in model performance because we're asking our function to approximate outside the domain that it is seen. I'm going to use a common example of spam email detection as a classification problem to illustrate this. So, data drift happens when the content and the features of the email change significantly. Perhaps our original spam detection algorithm was built on text-only emails. Data drift may look like a situation where now we're receiving emails with minimal text and a lot of attachments and hyperlinks. Concept drift happens when the concept represented by the approximated function changes over time. So the input variables have not changed, but the same X input now results in a different Y outcome, causing incorrect predictions from our model because our function was trained under the assumption that our X input gave a Y outcome. But now we see that outcome is no longer true. Coming back to the spam detection algorithm, concept drift may look like a situation where an email was originally not marked as spam, but later an email with the same features was marked as spam. The concept of what makes a spam email has changed. Longevity and maintenance portion of MLOps can help remedy this decrease in model performance by first detecting model drift at the source by using monitoring for incoming independent feature variables and model evaluation metrics. And then by retraining machine learning models via our automated model training pipelines and incorporating the new data we've seen. Both data drift and concept drift involve statistical change in data. Data drift in the independent feature variables and concept drift in the dependent target variables. This allows us to detect drift by monitoring incoming data and model performance and comparing what we see versus what we expect to see. Back to that spam filter example, we can look at our incoming feature variables of our emails and compare them to the statistical properties of the emails in our training set. If we start to see the statistical properties of our incoming emails diverge from that of our training emails, we're likely starting to see data drift. And if we're not seeing signs of data drift, but our model metrics, so typically precision for the case of the spam filter problem, begins to worsen and deviate from what we had seen in our initial test set or what we had seen in early production runs, we're likely beginning to experience concept drift. When we detect drift, we can automatically trigger our model training pipeline to freshen up our model and increase our performance. But using drift detection to kick off model retraining isn't the only method. Sometimes we simply do not have the time or the resources to dedicate to drift detection. In this scenario, we can choose to retrain on a scheduled cadence, maybe once a month, for example. The downsides to training on a scheduled cadence are maybe we experience poor performance if drift occurs prior to model retraining, and potentially sometimes we're unnecessarily retraining our model when we don't have any drift occurring. But we can also choose to retrain when we detect drift to remedy these extended periods of poor performance and unnecessary training. I hope you've seen how you can use MLOps to build an integrated machine learning system and to continuously operate it in production, both in development and deployment by using the principles of CI/CD to walk up the levels of MLOps maturity, and in longevity and maintenance by detecting model drift and having a plan for model retraining to ensure model performance even after deployment. I really enjoyed the opportunity to speak with you all today. Feel free to follow up with any questions or comments you may have about this talk. The QR code here will take you to my email, or you can go ahead and connect and reach out to me on LinkedIn. I put my link there as well. Also, just a quick plug, CGI is hiring data engineers and data scientists, so feel free to scan that QR code and shoot me an email with your resume and we'll get back to you. So thanks so much for your time today. I hope you all are really enjoying PyOhio and have a great day.